and welcome to Climate Chat. I am your host, Dan Miller, and today we have a special guest, renowned climate scientist Ben Santer. Who, Ben, I don't know if you know this, but we met long ago at some UC Berkeley climate event and a few other times along the way. But Ben has been doing climate science for a long time. Semi-retired, I think, is the proper way to put it. Is that right, Ben?
I think it's fair to say that I'm failing retirement 101 pretty miserably, Dan.
Okay, maybe we'll get into some of that. Before we get started, just very briefly, next Sunday, July 27th, climate scientist Peter Cox from the University of Exeter. He'll be interviewed actually by Leon Simons because I have a family event to attend. And then a special day, Thursday, July 31st, Stephen Chu, former energy secretary, Nobel Prize winner, et cetera. Maybe we'll get into a little bit there about the politics as well. But Ben, you're best known, well, for many things actually, but you spent a lot of your career talking about how we know that humans have influenced the climate. Maybe you could just give us a broad overview about when did we first know this, and when were we pretty sure of it, and these kinds of things.
Well, I've been involved with what's called climate fingerprinting since the late 1980s, and climate fingerprinting seeks to separate human and natural climate change using pattern information. The idea is that just like fingerprinting in forensic science utilizes different whorls and ridges that people have on their fingers, different things that influence climate have different characteristic signatures as well. So what do I mean by that? Changes in the sun's energy output don't do exactly the same thing to climate as large volcanic eruptions, or as human-caused changes in greenhouse gases, or as natural climate variability associated with El Niños and La Niñas. So the basic premise in fingerprinting is that patterns have discriminatory power. Geographical patterns of climate change, say, at the Earth's surface, or patterns of climate change in the ocean, or patterns that go from the surface right up to the stratosphere, the top of the stratosphere, 50 kilometers above the Earth's surface. If we look at those complex geographical or altitudinal patterns of climate change, then we can separate the sun's effects on climate from volcanic effects on climate, from human effects on climate. And that's what I've been doing, fingerprinting the climate system for really the last 40 years or so.
Wow. So speaking of 40 years, can you just give us a little bit of your background, like where you worked, where you were doing this work?
And my apologies for the local signal to noise problem in the background here. We had a power outage up here in Southern Oregon, and the smoke alarm is chirping because the power is just coming back online. Hopefully that annoying noise will go away relatively quickly.
Not too bad.
Back to my personal history.
Yeah.
So my life changed profoundly because of one tennis match. So back in the early 1980s, I was attending a conference in Aerosols in Sicily. I was doing my PhD at the time at the University of East Anglia in the UK. And at this conference, I played a game of tennis. A guy came up to me afterwards and said, I'm Klaus Hasselmann. Hasselmann was then one of the 3 directors of the Max Planck Institute for Meteorology in Hamburg, and he was working on fingerprinting the climate system, on developing mathematical techniques to disentangle human and natural effects on climate. So Hasselmann, the great man, even back then in the early 80s, says, do you want to have a game of tennis? I immediately say yes. That game of tennis led to an offer to go to Hamburg to talk about the work I was doing for my PhD, which I did. And that then, visit to Hamburg, led to the opportunity to do a postdoc there. So that one game of tennis fundamentally changed my life, because when I went to Hamburg in September of 1987, Hasselmann gave me a copy of a paper that he had written about fingerprinting way back in 1979 and said, here, this is a good problem for a young man. Try and figure out how to translate these ideas about climate fingerprinting into working computer programs. Let's do this in the real world. And that was my job in 1987 and has been my job ever since, to try and use pattern recognition techniques to separate human and natural effects on climate.
Well, I guess I'm asking on behalf of everyone listening, who won the game?
I can't remember who won the game, but I'd have to say that that one game really did change the entire trajectory of my life. And it's interesting to think how all of us have those moments of serendipity where something happens and you're nudged onto a completely different trajectory. In my case, that different trajectory was fingerprinting the climate system and trying to understand how human actions, like the burning of fossil fuels, have influenced our planet's climate.
Yeah, I mean, I guess we could say the Earth's trajectory is, yes, being influenced right now in the special moment of time where we learned about fossil fuels. Okay, let's take it back a little bit. I first got engaged in climate in the early 90s. I read a magazine article by Bill McKibben, and he was talking about Svante Arrhenius, who had realized we're burning fossil fuels. That's putting CO2 in the atmosphere. That's going to increase the temperature. Let's take a crack at how much the temperature would increase if we happen to double CO2, which he thought, I think, would take like 3,000 years at that point. But so back then there was a knowledge, that CO2 influences the climate. So would you say we did we know then, or was it, that's 3,000 years from now, so let's not worry about it? Or when did what were the earliest times back then? I can put up, by the way, here is Svante and his first paper he wrote. Let's see. The first paper he wrote in 1896 about what happens if we double CO2 in the atmosphere. Back then, CO2 was called carbonic acid. So
I would say that dawning recognition that human-caused fossil fuel burning and the production of carbon dioxide had the potential to influence our planet's climate preceded Arrhenius. Eunice Foote in the United States in the late 1950s actually was one of the in the late 1850s was one of the first to perform simple experiments to show the heat trapping properties of CO2. Her husband actually read the paper at a scientific meeting because she wasn't allowed to as a woman. That was really a seminal contribution. And at the same time, John Tyndall in the UK was looking in the lab at the radiative properties of CO2 and water vapor and other greenhouse gases. So the late 50s and early 1860s were a time where there was this dawning understanding that burning fossil fuels might change the planet's climate. Then along comes Arrhenius to do some of the first calculations with a simple climate model and understand the consequences for the average temperature of Earth's surface of doubling CO2. So all of this is happening in the late 1800s and early 1900s. We're beginning to understand that human actions, deforestation, and the burning of fossil fuels have the potential to alter global climate.
Would you give Guy Callender the credit for seeing the increase for the first time? Was he? I don't even know if that was actually a correct thing he saw, or that was just some noise. I'm not sure, but
Yeah, I think that Callender is generally credited with trying to come up with some of the first observational estimates of large-scale changes in surface temperature,
yeah.
and to claim that the planet was warming and he could see that in the data. Surface temperature records at major European cities, for example, had started in some cases in the early 1800s. People began to make measurements of temperature in Paris and in Italian cities, and of course at Kew in the UK. So there were these records at a number of European cities, but Callender and others made an attempt to put all that stuff together to get a larger scale picture of surface temperature change.
And then one I think doesn't get a lot of credit, but Gilbert Plass wrote some seminal papers the year I was born, I guess, and carbon dioxide and the climate, and really laid out how dangerous this could be and everything, and
Yep.
didn't get much coverage, but we seem to know back then. That's what I'm trying to get at. I mean, there's the work you did where we say we really know. I mean, like, this is the scientific consensus, and we're going to get into that in just a moment. But even back then, people were writing articles. Hey, this is not going to go well. And then, of course, then there was David Keeling, but Jim Hansen testifying in 1988, warning us about this. And so there was this sense starting in like the 50s, I guess, that there's something going on here that could end up not being good. Would you agree with that?
Yeah, I would agree with that. The data was accumulating, the surface temperature measurements. We were launching weather balloons really in the early 1900s. Tesserang de Boert and a German, Richard Assmann, were starting to make measurements not only at the Earth's surface, but in the free atmosphere. And we were beginning to understand that temperature was changing at the surface and in the atmosphere. And that led to the work of Plass and later to the work of Phil Jones and others. Phil Jones at the Climatic Research Unit, Chris Folland and others at the Hadley Center, to try and compile a truly global estimate of surface temperature change.
And then so now we're going to zoom forward. So we had all this warning, but then IPCC was formed, and there were all these international conferences to understand things. And at first, I was actually a little surprised. It was like the IPCC was hesitant about saying whether we really know that humans are causing climate change, like in 92 or that time frame. Is that right? Or is it?
No, so the IPCC was set up in 1988 by the World Meteorological Organization and the United Nations Environment Program, UNEP, and their first report came out in 1990, their first assessment report. And that first report concluded famously in its chapter on climate change detection and attribution that the jury was still out,
right,
and that I believe their exact words were something like this: unambiguous identification of a human signal is not likely for at least another decade. That was in 1990. But of course, in 1995...
Very catchy phrase there, right?
Yeah. In 1995, so just 5 years later, the second IPCC report comes out, and it reached a very, very different conclusion regarding the identification of human effects on global climate.
Right. And these are the famous words that I understand you penned for the report, because you're working on the report. And you said in 1995, the balance of evidence suggests a discernible human influence on global climate. And so that was the first time, right, that the scientific community said, hey, humans are causing climate change, like with a reasonable amount of certainty. Is that correct?
Well, those 12 words, the balance of evidence suggests a discernible human influence on global climate, were finalized on November the 29th, 1995, at this famous plenary meeting of the IPCC in Madrid in Spain. In my opinion, it really was the first time that the international scientific community spoke with one voice and said, formally, we can identify some human-caused climate change signal. That signal has risen above the background noise of natural climate variability. So it was a big deal. And
impacted your life quite a bit, I understand, as well. We're going to get into, right?
It did impact my life quite a bit, but in retrospect, it was a historic occasion. It was the scientific equivalent of the handwriting on the wall. Scientists were saying something unusual is happening, and we may ultimately need to reduce emissions of greenhouse gases. I think that very few of the scientists in the room in Madrid on November the 29th, 1995, understood the full implications of that 12-word finding, but others did. Many of the government representatives, say from Saudi Arabia, from Kuwait, an industry lobbying group, the Global Climate Coalition, they understood all too well the implications of that cautious, even wimpy balance of evidence suggests a discernible human influence. They knew that this might affect their bottom line. It might affect the way that they had to do business.
So let me ask you that. So when we talk about scientific, you're going to write a scientific paper on a subject. You want to be fairly sure that you're right, because if you publish something that's wrong, it's going to ruin your reputation. If you don't publish something that turned out to be right, nothing really happens because you didn't write anything. And so you're usually shooting for like a 2 sigma, 95% assured that you're correct. Is that what this statement reflects, sort of a 95% certainty, or was it more amorphous than that?
This was more amorphous than that. It was in the fourth assessment report of the IPCC in 2007 that they introduced, the IPCC, introduced this calibrated likelihood language where things like very likely and extremely likely had specific probabilistic meanings. Back then, in 1995, we didn't have that calibrated likelihood language yet. The IPCC hadn't introduced it. Our job as the scientists, roughly 24 of us, involved in Chapter 8 of the IPCC's 1995 report, was to assess over 130 different scientific studies that used very different methods to look at human effects on climate. Some looked at only global mean changes in surface temperature. Some of these studies did fingerprinting with patterns of surface temperature change or patterns of temperature change through the atmosphere. The challenge for the several dozen scientists involved in this critical chapter in 1995 was to synthesize and assess the information from all of these different studies that had tried to look at human effects on climate. And that's what led to these 12 words. The balance of evidence suggests a discernible human influence on global climate. Like I said, subsequent IPCC assessments decided, hey, wait a minute, we're going to need to introduce calibrated likelihood language in order to better express the collective certainty or lack thereof in findings of a human effect on climate. Does that make sense?
Yeah. And we're going to jump around a little bit in time here. Let's zoom up till today. What what modifiers would you use on that, or how would you phrase that sentence today? Certain?
Well,
Nearly certain?
well, the IPCC, in its most recent report in 2021, this is the 6th assessment, used this incredible word, unequivocal. It is now unequivocal that there are human fingerprints all over the climate system, in the oceans, at the Earth's surface, in the atmosphere. We know beyond a shadow of a doubt that human-caused fossil fuel burning and the production of heat-trapping greenhouse gases, deforestation of the land surface, has altered global climate. And we can see those fingerprints in literally dozens of different independently monitored variables, not only temperature, but also atmospheric moisture. Think rainfall, think the total amount of moisture in the atmospheric column. We can identify human fingerprints in the ocean, in ocean heat content, in clouds, in cloud location, cloud altitude, cloud radiative properties. We see human fingerprints in the retreat of Arctic sea ice, in sea level rise patterns. We see them everywhere, and increasingly in extreme events as well, in terms of changes in the statistical properties of extreme events, like heat waves and extreme flooding events. The power of this fingerprint evidence, again, fingerprinting is fundamentally about looking at complex patterns of change, is that it's internally and physically consistent. These are measurements that are not made by one group or a few groups of scientists. These are made by hundreds of groups around the world using fundamentally different platforms from space, from satellites, in situ at the Earth's surface, in the depths of the oceans, using weather balloons, all kinds of different measurements, and collectively they tell us that the patterns of climate change that we've observed and monitored in dozens of different variables can't be explained by the sun, by changes in volcanic activities, or by natural internal variability. Think El Niños, La Niñas, Pacific decadal oscillation, and all that stuff. The only explanation for those changes that fits the bill is a strong human effect on climate.
So maybe, if you're the number one climate denier myth is that the climate has always changed, which is interesting because it's kind of true, but not the implications of the question, which is either therefore it's naturally caused or therefore it's going to be safe, both of which are not true. But how do you have a quick way you respond to people when they bring up, hey, the climate's always changed?
Well, that is true. Climate has always changed. The problem is that the changes in climate since the Industrial Revolution, so since the 1800s, are not natural. How do we know that? How do we know that all the changes I just talked about in temperature and moisture and clouds aren't just natural, like the stuff that happens on ice age timescales, which is what these critics are referring to when they say climate has always changed. How do we know that what happens on ice age timescales in deep time isn't the same as what we've measured and monitored since the 1850s? Well, we know because we've tracked changes in the chemical composition of the atmosphere. You showed that, Dan. Charles Keeling's famous measurements, now imperiled at the Mauna Loa Observatory in Hawaii. We've measured dozens of trace constituents, and we know that the changes in those trace constituents, CO2, methane, chlorofluorocarbons, are not natural. Some of these substances we pumped into the atmosphere, like fluorocarbons, potent greenhouse gases, are not naturally occurring substances. We know from looking at isotopes of carbon, heavier and lighter isotopes, that most of the increase in CO2 from 1850 to the present, from roughly 250, 260 parts per million in the 1850s to over 420 today, that's on us. That's fossil fuel burning. All of this is not subject to debate. Those human-caused changes in the chemistry of the atmosphere since the 1850s are a fact. They're hard science. The reasonable discussion has always been about, well, okay, given that fossil fuel burning and deforestation and production of particulate pollution has changed the chemistry of the atmosphere, how important have those changes been for Earth's climate? And that's where fingerprinting comes in. For example, let me give you a quick for example here. Back in 1967, Suki Manabe and Dick Weatherald at the Geophysical Fluid Dynamics Lab in Princeton published a paper in which they used a very simple computer model of the climate system, a so-called radiative convective model, to increase CO2 from 150 to 300 to 600 parts per million. And when they did that, in this simple model, they saw that the lower atmosphere, the troposphere, warmed, and the upper atmosphere, from about 15 to 15 kilometers, the stratosphere, cooled. And that was because with increased CO2, we more effectively trap heat in the lower atmosphere, and the upper atmosphere cools. And that cooling of the upper atmosphere increases the higher up you go above the Earth's surface. This is 1967. It's a true prediction that Manabe and Weatherald made in this paper. We didn't have the satellite measurements to reliably determine whether their prediction was right, whether the troposphere was warming and the stratosphere was cooling. We had some weather balloon measurements of atmospheric temperature, but the weather balloons back then didn't have the structural integrity to get high up into the stratosphere. They burst. So Manabe and Weatherald could have been wrong. They weren't. They were right. Subsequently, the weather balloons, the satellite measurements of atmospheric temperature confirmed that prediction made in 1967. When you increase CO2, you more effectively trap heat low down, the upper atmosphere cools, and that fingerprint is unique to human effects on climate. Changes in the sun can't do that, changes in volcanic activity can't do that, and natural intrinsic variability, El Niños and La Niñas, can't produce a fingerprint like that sustained over 40 years. And that's what we've seen. That's what we see in the weather balloon data and the satellite data. That's the power of fingerprinting, and that's the power of NOAA. Everything of the National Oceanic and Atmospheric Administration. So that fingerprint work relies on NOAA satellite measurements and relies on NOAA computer models and relies on that fundamental physical understanding that Manabe and Weatherald gained back in the 1960s with simple climate models. You hobble NOAA, as this administration is now trying to do, you make it difficult to do the fingerprinting work that provides such powerful evidence for human effects on global climate.
I think that's the point. That's the feature as they consider it, not the bug. I mean, they don't want scientists to be able to say with certainty, which we already can, of course, that humans are influencing the climate in a negative way. And that's what part of what's happening. Maybe we'll get into that a little bit more. I want to get your thoughts on what all of that. You in a speech you gave, you did something interesting. You went back to, I think, 1885 or something and said, hey, what if we had the scientific instruments to measure things back then, satellites and things like that? Would we be able to tell back then in the late 1800s that the humans were influencing the climate? What can you tell us just a little bit about that?
Well, thank you for asking about that. This paper that you referred to was published just last month.
Oh, okay.
And it's something I've been obsessed with for the last year. So it's a simple thought experiment that I performed together with Susan Solomon and Yao-Wei Li at MIT, Chung Fu at the University of Washington, and David Thompson at Colorado State University. And what we did in this paper was consider a simple question: when could we have known it was us? If we had today's climate modeling, climate monitoring system back in 1860, and had been capable back in 1860 of measuring atmospheric temperature change from the surface right up to the stratosphere, how long would it have taken us to say with a high degree of confidence that something funny was going on, something that wasn't purely natural, not due to changes in the sun or volcanic activity or to natural internal variability of the climate system, El Niños and La Niñas? We didn't know. It turns out that this type of question, when could we have known first that humans were affecting global climate, is understudied. And we were surprised to learn when we did this thought experiment using computer model simulations from 1860 through to the present, you can do the fingerprinting with those model representations of how climate might have changed from 1860 through to the present. And you can answer the question. And the answer was 1885. We could have known by 1885, if we had been able to monitor temperature changes in the stratosphere, that cooling signal predicted by Manabe and Weatherald was there. So even though back then in 1860, human-caused fossil fuel burning and human-caused deforestation are only leading to a relatively modest increase in CO2 in the atmosphere, that increase of roughly 10 parts per million from 1860 through to 1900 was enough to generate a discernible stratospheric cooling signal. That was a surprise to us. The bottom line is we could have known before the advent of gas-powered cars that our actions were altering global climate.
So not just that you could measure 10, because, by the way, 10 was a lot, I guess, relative to an ice age, was a drop of 100 in total, right, going into the ice age. So 10, but you're not saying just the measurement of the value, but you're saying the impact of that 10 parts per million you would have been able to discern back then.
That's what we're saying, yeah. That if we had the capability to measure temperature changes in the stratosphere, we would
cooling of the stratosphere would have been, you would be able to pick that up.
Yeah. Why? Well, it turns out that the stratosphere is an environment that is really favorable for trying to identify a human effect on climate, because the pattern of human influence, this Manabe and Weatherall predicted pattern back in 1967 of cooling of the stratosphere, cooling pretty much at all latitudes, and cooling that gets larger the higher up you go above the Earth's surface, that pattern doesn't look like patterns of natural variability in stratospheric temperature. And that helps you, getting back to Hasselmann, that difference between the human fingerprint and patterns of natural climate variability. If those patterns are very different, it's a favorable situation for identifying a human signal. And that's what the stratosphere has to offer. also, it turns out that, at least in global mean terms, the noise of natural variability is relatively low in the stratosphere.
Oh, okay.
So that's why we get this rather startling result that if we had started monitoring temperature in the stratosphere in the 1860s, 25 years later, by 1885, we could have said with high confidence that the changes were not natural. There was a strong human fingerprint on the climate system.
And in those early days, like up until, I guess, the 1920s or something, we didn't really see the temperature going up. In fact, sometimes the global mean temperature went down. But my understanding is that's because we were putting out pollution, putting out aerosols faster than we were putting out CO2 in terms of the impact, I guess. And therefore, we were actually cooling the Earth a little bit back then because of from our pollution. Any comments or thoughts on that?
Yeah, that's exactly right. At the Earth's surface and in the lower atmosphere, you have two things, at least two things going on that have important influence on global scale temperature. One is the warming influence of fossil fuel burning and changes in CO2 and other greenhouse gases. The other is particulate pollution associated with things like these sulfate aerosol particles. So sulfates, in regions where you have heavy atmospheric burdens of sulfate pollution, tend to reflect some incoming sunlight back to space, to scatter it, and cool the underlying surface. Mm-hmm. In the 40s, we started really ratcheting up the sulfate pollution with deleterious consequences for the environment. Think acid rain, think changes in pH in lakes, death of forests. And as there was this emerging recognition in the 50s and 60s that unchecked sulfate pollution was really, really bad, people started responding and putting in a lot of effort to reduce sulfate emissions, say, from coal-fired power plants. So that, and in the US, the Clean Air Act happens in the 70s. Yeah. We make a concerted, really bipartisan effort to reduce sulfate pollution. And as Jim Hansen and many others have pointed out, that led then to some more unmasking of the underlying human-caused greenhouse warming signal, because the sulfates are, in the net, a cooling influence on climate. When you reduce sulfate pollution, and this is what Jim Hansen has referred to as this Faustian bargain.
Deal with the devil.
You more clearly reveal the underlying human-caused global warming signal.
I think it's happening in China right now. They had this first national level heat emergency, crazy temperatures across China. And of course, they've been doing a lot now for what we did in the 70s to scrub the sulfur from, and that aerosol is a local phenomenon, right? It's a cloud that you put over your country or, region, as opposed to CO2, which gets well mixed pretty quickly into the atmosphere. So, and Europe's seeing it too, because they cleaned up a lot.
Yep.
And they're the fastest warming continent. So that's a big one. Speaking of going back in time, Jim Hansen and Leon Simons, our co-hosts, wrote a paper, Global Warming, the Pipeline, and some follow-up papers that say, hey, you can see human influence going back, I think it was 4,000 years, if not 8, but I think it was like 4,000 years because of land use changes, growing rice, which creates methane. Have you looked at that at all, going back that far, and whether we would have been able to see a human fingerprint, or whether we see it looking backwards, I guess?
Yeah, that's a really interesting question. And I think it was Bill Ruddiman who first published on this so-called early anthropogenic hypothesis. And in Bill's publications, I think he posits that going back 6,000 to 7,000 years, you could likely see some imprint of human activities, primarily deforestation and then later rice production, on levels of CO2 and methane. So with appropriate simulations, one could do the kind of thought experiment that I told you about with atmospheric temperature. One could go back and try and say, well, if Ruddiman was right, and if those changes in atmospheric composition in CO2 and methane were caused by us, by deforestation and by rice production, when could we have seen an even earlier signal of human effects on climate? So my hope is that these fingerprinting offers a method for looking at those types of questions and answering the when could we have known about a human effect on climate using rigorous statistical methods.
Okay. So let's zoom up closer in time here. Let's go back to 1995. You published that, hey, humans are causing climate change. And I understand that after this time, you got hit with a lot of stuff, the backlash from the fossil fuel community, from political figures tied to the fossil fuel community. Can you talk a little bit about that? I think it's important for people to know that climate science is not just something, just this academic thing like studying astronomy or something like that. It has these ramifications that people might be a little bit surprised and even shocked about.
I was so naive, Dan. I had no clue what would happen after those 12 words were published by the IPCC. The balance of evidence suggests a discernible human influence on global climate. It was clear in the spring of 1996, after the infamous meeting in Madrid at which those 12 words were finalized, that very powerful individuals and organizations hated that finding. It meant that they might have to change the way they do business. And they waged an all-out war on the science, on the IPCC, and on the individuals involved in that 12-word discernible human influence finding. Unfortunately for me, I was the convening lead author of the chapter in which that finding was situated. So the name of the game was go ad hominem. If you can't win on the science, then go after the person involved in the report, try and argue that they are guilty of political tampering, scientific cleansing. These are words that were bandied about at the time in 1996, that they have ulterior motives, that they want to subvert world systems of government. All sorts of crazy stuff came out at the time. My interest and the interest of my colleagues involved in the report back in 1995 was to produce the best possible summary and synthesis of the then available scientific evidence, to get the science right. And we did. Mm-hmm. As I mentioned, subsequent IPCC assessments after 1995, the third assessment report in 2001, the fourth IPCC report in 2007, the fifth in 2013, the sixth in 2021, they upped the ante. Mm-hmm. They went far further than our cautious, wimpy balance of evidence suggests. Mm-hmm. And the logical endpoint of that was 2021. It is unequivocal that there are human fingerprints in the atmosphere, the oceans, and the land. So the fossil fuel industry understood in 95 and 96 that they had to try and engage in a scorched earth policy to go after the science, to go after the scientists, and they did. And that was systematic. It involved efforts to investigate my sources of funding, for example, at the Lawrence Livermore National Lab, where I was employed back then. Dana Rohrabacher, a congressman in the US Congress, led those efforts. There were letters in the Wall Street Journal, most famously from Frederick Seitz, a past president of the US National Academy of Sciences.
George C. Marshall Institute. That did the whole thing about try to make smoking seem okay. Yeah, those guys.
Yep.
Merchants of Doubt.
Read Merchants of Doubt by Naomi Oreskes and Eric Conway, a terrific book. And when I read that, it became clear that the very individuals, the same individuals who were attacking me back in 1996, had previously been on the wrong side of the science of ozone depletion, acid rain, cigarette smoking, and cancer, you name it. It was a playbook. It was a pattern of behavior. If you don't like the implications of the science, then go after the scientists and do everything you possibly can to sow doubt. Mm-hmm. I encountered those merchants of doubt in the summer of 1996. And it was serious. You know, Seitz, in this letter in the Wall Street Journal in June 1996, named me and accused me of the worst violations of the peer-reviewed system he had seen in his 60 years as a scientist. Okay. Others called for my dismissal with prejudice from my position at Lawrence Livermore. One gentleman circulated an email in which he said that I was about to be indicted by the Hague International Court of Justice for, quote, falsification of international scientific relevant documents. Nothing in your scientific career prepares you for something like that. As a scientist, you're trained to defend your findings in the scientific arena, mm-hmm. to justify the appropriateness of the methods you use, the inferences you draw, but you're not prepared to defend in a very different arena your integrity, your decency, your honesty. That's
was Lawrence Livermore helpful in supporting you, or it's like I think if it was a university, it might be a little different, but this is a government lab, or did other people come to help in organizations?
Well, back then, so this is in the spring and summer of 1996, when all the bad stuff is hitting the fan, so to speak. Lawrence Livermore National Lab was managed by the University of California,
right,
or the Department of Energy. So it was prior to the time when management of most of the national labs changed. After the Wen-Ho Lee affair, Congress wanted the Department of Energy to recompete the contracts to manage the labs. And, fortunately for me, I guess, that recompetition, which led to other entities taking over the management of the labs, in Livermore's case, a consortium run by Bechtel.
I didn't know that. Okay.
Yeah, but in 1996, it was the University of California, and they cared about intellectual freedom. And I would say that the lab was supportive, the University of California was supportive, but it took a little bit of time until that support manifested. These were serious allegations, and perhaps understandably, Livermore and the UC wanted to know, who is this Santer guy who works for us, and why is he getting attacked in the Wall Street Journal and by the Global Climate Coalition? And why are senators and Congress folks writing to the President of the United States complaining about his behavior? What the heck is going on here?
But now we know, looking back,
pretty quickly, support did coalesce. The IPCC weighed in through the chairman of the IPCC, Bert Boleen, and clearly said these allegations that Santer behaved unprofessionally in his role as convening lead author of this critical chapter of the 95 report, those allegations are wrong. And the discernible human influence finding was signed off on by all 96 countries present at the Madrid meeting in November 1995. That was really, really encouraging to see that support develop. The American Meteorological Society came to my defense and wrote an open letter in support of me, in which it pointed out the criticisms in the Wall Street Journal from Seitz and others, and our responses, so my response and the response of other authors involved in the 95 IPCC report, and the response of IPCC individuals who had been there in Madrid. And this open letter from the American Meteorological Society showed how the Wall Street Journal had edited and cut the responses to these very serious allegations. So the allegations were there in full, but the responses in the Wall Street Journal were not published in full. So all of this stuff came out slowly, and in the end, I think one of the most significant events for me was the Global Climate Coalition, this consortium of energy interests that was at the forefront of attacking me in the summer of 1996. They folded. Why? Because a number of their constituents decided that their interests were not well served by remaining in the Global Climate Coalition, that the way forward was not to attack individual scientists. And that was really encouraging to me in the fall of 1996, this recognition that the tone of the debate matters, and there are risks to trying to go nuclear and destroy science and destroy scientists. Hopefully people understand that those same risks exist today, that if you want to take this country back into the dark ages, you will fail. You can't extinguish understanding in the end. And history will judge you harshly for attempting to destroy knowledge, to consign mature science to a memory hole.
Yeah, but this, by the way, I had a chance to, debate or something, former, I think it was Bill O'Keefe, the guy who came after Seitz, on an online forum that we were both climate forum we were both part of. And I have to say, maybe you'll like to know this, but he was in Merchants of Doubt, right? And when he's putting all this BS about, he was like the biggest climate denier, saying things that have been debunked over and over and over again, and yet he kept going at it. And then I would bring up, well, you're in the Merchants of Doubt and everything like that. You could tell he really hated that. So just to let you know a little bit. But those same people, by the way, are still around. Richard Linsden was on the advisory board for the George C. Marshall Institute. He was, I think, just appointed by Trump to be, we're putting climate deniers in charge of, climate science or something in the administration. So maybe it's a good time to ask you what you think of the purposeful destruction of climate science and shutting down of climate information from the U.S. government, and what impact do you think that's going to have over the short to longer term?
Well, I've written about this a lot in the last couple of months or so, and I've spoken about this willful destruction a lot. And even under the first Trump administration, I wrote about the dangers of embracing ignorance with open arms, which is what we're doing.
Yep, idiocracy. Yeah.
It harms everyone. So ultimately, if you're an elected representative, senator, congressperson, you have some other elected position, your prime directive is to keep the people who voted for you safe from harm. You would think. And yet, these decisions that the Trump administration has made in the first 6 months put people in harm's way. Canceling the jobs of people developing next generation hurricane track forecast models, firing NOAA employees who launch weather balloons that provide information that feeds into weather forecasts, talking about turning off satellites that provide moisture data that feeds into weather forecasts, firing probationary employees and even permanent employees who develop better models for forecasting extreme weather, better instruments for looking at extreme rainfall, removing information from government websites like national climate assessments, as we learned recently, that give us reliable information on the reality, seriousness, and impacts of climate change. All of those things make no sense if your prime directive is to keep people safe and give them the tools and the knowledge to understand how and why their world, their climate is changing. No, this is unacceptable. It should be unacceptable to every US citizen. As we see from the tragic events in Texas and Asheville last year, as we warm the planet by burning fossil fuels, as we increase the moisture in the atmosphere, we get more severe extreme rainfall events. And we change the statistics of heat waves as well. Those things are not academic. They have serious practical implications for people's lives, people's health, people's livelihoods, where they can live. Consigning what we know about this stuff, consigning climate science to a deep memory hole is, in my opinion, tantamount to a crime. It really is.
So I have and I don't call it a prediction, I just call it a scenario, because who knows what's going to happen. But the fact that the Trump administration is not only, is clearly saying, hey, I don't believe in climate science, I'm not going to do anything for the climate. There's no doubt, right? They're saying it themselves. And yet the climate damage is going to occur. It's going to occur. Not really because of Trump's current administration, but because of all past administrations and around the world. We just haven't done anything for climate very much. So do you think that there's maybe going to be a quote silver lining, in that people might actually associate inaction on climate with climate damage and therefore want more action on climate in the future? After they get more of the Texases and the North Carolinas and whatever else is to come in the next 3 years or so.
Well, one of the other things the government has done is it's, as I understand it, now giving up on tracking billion-dollar disasters. So that the very information that people need about the economic consequences of natural disasters and how that has changed as a function of time with human-caused climate change, the US government doesn't want to provide that anymore. Again, it seems deliberate, right?
Of course.
keep us from understanding not only how and how fast and by how much climate is changing, but also to keep us from understanding the implications of that. That's where I believe it's incumbent on scientists to speak science to power, incumbent on the media to try and ensure that facts, that this basic understanding gets out there and reaches the general public. We have to find innovative ways of pointing out the fierce urgency of now. We
Right.
have a relatively narrow window of opportunity to get all this stuff right, to figure out effective responses to reduce emissions of greenhouse gases. If we don't, then future generations who have done nothing to create this problem will be saddled with a lot of suffering. I think that is morally and ethically completely unacceptable.
Yeah, well, yeah, and I agree with you. In fact, on this channel, we actually focus a lot on that issue that you're bringing up. So not only do we interview climate scientists, but we interview communications experts and psychologists and people taking direct action and things like that, because from my point of view, we actually know all the climate science we need to know. We're going to get more, but we have enough to know we're in danger, and we also have the solutions, yet we fail to deploy them at the scale we need. So there's something else happening, and that is what you're bringing up, which is there's a failure of communication. And I wonder if you could comment a little bit on that, because, even the IPCC, I think some give it criticism, not what sites and everything would do, but the opposite, in that it's being far too conservative, sort of in the science, but also in communicating the dangers that lie ahead. And that they're not using the kind of language that scares people. And yet, if it was in any, if it was like how safe is an airplane or something like that, then people would be, would never get on that airplane that had the same probability as crashing as the climate. Any thoughts on how science, IPCC, or that side of the world can improve its communications to get the public more engaged?
Great question. I struggle with trying to answer that question. I think we have failed as scientists to explain the richness of the evidence for a large human effect on climate. So let me take you back. 1995, discernible human influence finding. One of the justifiable streams of criticism of that 1995 finding was, oh, you scientists are just looking at surface temperature measurements. Mm-hmm. If there really is a human-caused climate change signal lurking in observations, show us. Show us that it's in the oceans. Show us that it's at the top of the atmosphere, that it's in moisture, that it's in clouds, that it's in snow cover, that it's in sea ice. Convince us. And we did. But I think the public doesn't understand how overwhelming the scientific evidence for a pronounced human effect on climate really is. We need to find better ways of communicating that rich internal consistency of the evidence, of communicating that scientists are inveterate tire kickers. We're our own fiercest critics.
Right.
We're constantly reevaluating the evidence, the observations, the models, the basic theory, to see, could we have made mistakes here? How do we reduce uncertainties? We haven't conveyed that tire kicking very well either, I would argue, which is what breeds calls for, say, this kind of red team, blue team adversarial reassessment of climate science by people like Steve Koonin, who's now been appointed to some role in the U.S. Department of Energy.
Another
folks like
quasi-denier
Koonin,
or apologist or something. Yeah.
Yep. Koonin, for a long time, has argued that the science of climate change is unsettled and that mainstream climate scientists have failed to do a good job with the science, that only really bright physicists are capable of fairly assessing the science. And what we need is to have some adversarial red team, blue team reassessment, relitigation of science that we've been doing for 50, 60, 70 years. And Steve Koonin, should be in charge of this.
That's on one side. That's the denier side. So let's actually, I think it's somewhat more interesting that among the climate scientists themselves, or maybe an outside view of the climate scientists, and this actually comes from a YouTube question here, so we'll get into the audience questions. How does Ben feel about the two factions in climate science, Michael Mann versus Jim Hansen, aka moderates versus climate alarmists, and the hate of the so-called minority called doomers? So, like, man, I mean, some people use the phrase, we're smoking hopium here, that everything's going to be okay as long as we cut our emissions, which doesn't seem to be true anymore, by the way, if that's all we do. And versus Hansen, who's saying the climate sensitivity, which we kind of alluded to in the earlier, is 4.5 degrees instead of the IPCC's 3 degrees, which means there's a lot more warming in the pipeline, if that's true. And so what's your thoughts on that? Like, how, if you make things sound okay, you're not going to get the public to rise up and demand that their public leaders take action.
Well, Jim and Mike have reasonable scientific differences regarding the rate of warming. I think that's fair to say. And whether the rate of surface warming is or is not significantly accelerating. I don't really want to get too much into this issue because together with colleagues at MIT who are leading this kind of work, we're actively looking at this question. It's an important one. Is the rate of warming accelerating or not? Mm-hmm. But answering that question depends on which time period you consider, whether you're looking at the surface or whether you're looking at the lower atmosphere, what statistical methods you use in order to try and determine whether there is or is not statistically significant warming. I would say the jury is still out on this question of a possible acceleration in the rate of warming. And a lot more interesting work sparked by this discussion between Jim and Mike Mann is going to be published in the next few years or so. It's, I would say, an issue where controversy is leading to good new science. Also in terms of the changes in shipping regulations.
Certainly.
And the impact of a reduction in the sulfur content of marine fuels. It has been posited that, as we discussed earlier, that reduction in the sulfur content of marine fuels is partly responsible for some unmasking of the underlying CO2-induced global warming signal. The science signal, then, that has happened because of that discussion is modeling groups are performing simulations that try and bound quantitatively the temperature change that may have been caused by that change in marine fuels. All of this puts us in a better position scientifically to figure out whether the extraordinary warmth in the ocean in the last couple of years is whether we fully understand why it was there. So I think I'll stop there. Yeah. These issues about acceleration in the rate of warming. We'll have a better handle on them, I believe, in the next couple of years. The climate impact of marine shipping fuel changes, again, I feel that we'll have better quantitative answers to the contribution of that change to the extreme warmth in the oceans in 2023 and 2024. That's the way science proceeds. You know,
although the way you're making it sound, I think it would make the public go, well, they don't seem to know. There's uncertainty, right? Which, of course, uncertainty is not your friend. But if we were talking at a bar somewhere, and I asked you to take off your scientist hat but keep all the knowledge you have about what's going on, and then throw in potential for tipping points, the potential for hitting whatever temperatures we're going to hit this century on the path we're on, how dangerous would you tell me it is? Like from a person to person, rather than scientific point of view, but just in terms of danger to our families and to our country and things like that.
Well, speaking from a bar stool, I'm not at a bar, but I'm on a bar stool. Am I concerned? Of course. I've been concerned my entire career. The kind of stuff we've witnessed in terms of extreme events is not a vast scientific surprise. We knew when we warm the planet, when we moisten the atmosphere, we're going to change the statistics of extreme events, and that's what people will feel. That will harm people. That will cost lives. We're seeing that in real time. And far worse stuff is to come if we continue to claim that mature science is a hoax, a conspiracy, and the solution is to drill, baby, drill, rather than to reduce emissions of greenhouse gases. So, yeah, I'm concerned. I'm concerned about the world over the next 10 to 20 years. As these signals and extreme events manifest more, as global sea level continues to rise, you will generate the pressure to cause people to move, to protect their families, to move to places where they perceive it to be safer. And those pressures involving movement of millions of people can easily be used by politicians to remain in power, to try and circle the wagons, to close borders, rather than addressing the underlying issues themselves that generate the pressure for people to leave their countries, to go to places where they can live safely, where they can grow food, where they're not going to be wiped out by a hurricane or a flood or a tornado. We have to address the underlying problem, not pretend that the problem doesn't exist. I'm going to do everything that I can to ensure that people understand that this problem is real, it is serious. People are already dying because of climate change. People's health is already being impacted by warming and by air pollution. That's real. That's the reality of the world in which we live today.
And so we're going to wrap up, but any message you'd want to send to either young climate scientists or members of the public that are engaged on the climate issue, like the folks that listen to this program?
Yes. So we've spoken about some unpleasant events in my scientific life. Those are the background noise for me. Sometimes when reporters ask me, doesn't your life suck? All these bad things have happened to you, investigated by Congress, threats. My life doesn't suck. I've had the extraordinary privilege of working together with brilliant women and men all around the world on issues that matter to all of us, on doing science that people care about, that's important to get right. That's an extraordinary privilege. I don't feel that I'm a victim. I feel that I've been so fortunate to do this work and to be able to continue doing it today. Things like the thought experiment, when could we have known that humans were affecting climate? So if you're someone out there who's been impacted by this administration's cuts to basic science, to the ability to do this kind of work, to measure, to monitor, to understand how and why climate is changing, keep on trying to do it. That's my message to you. Find a way, no matter how difficult, to keep on doing this critically important work. Science has to survive. It has to keep living. We don't have the luxury of remaining silent. We don't have the luxury of stopping being scientists just because it's tough.
We do have one question from one of our co-mod, Eli Rabani, and Eli, what's your question for Ben?
Thank you. So you talked a lot, and this is a great presentation or discussion about teasing out, what is actually caused by anthropogenic factors. I'm wondering specifically, though, about droughts and crop failures regionally, such as in Syria before the Civil War and in the Horn of Africa, still present, and in Madagascar. And also what that says for the risk of synchronized crop failures in the future.
Well, thank you for that question. I'm certainly not the best person to answer that. Someone like David Lobel at Stanford or Noah Diffenbaugh at Stanford would be much better placed to answer that question. But if you take the larger meta view of things, we're changing the statistics of heat waves and drought. People have tried to look at where there's robustness in terms of model projections of future changes in drought. And there is some robustness. Folks like Noah Diffenbaugh at Stanford have tried to show where there are reasons for concern, so-called hotspots in projected temperature changes and drought changes. These things are not going to happen on an isolated basis. I think what COVID taught us is the interconnected nature of global society. If you start having systemic food crop failures, then the effects of that are not localized to one country. They ripple through the entire global economy. As we change the climate, we change where we can grow certain types of crop. As we change things, as I pointed out earlier, we also generate the pressure for people to move if they can no longer farm and grow crops where they used to. All of this stuff is worthy of the attention of the United States, but by withdrawing internationally from the IPCC, from the World Health Organization, from entities that look at global problems and try and understand them, we make the whole world less safe, ourselves included.
Yep.
Thanks.
Thank you, Eli. And yeah, I don't think Trump really cares about the safety of everyone. I don't think that's one of his main focus areas. But Ben, I want to thank you for taking the time to share your knowledge with us and your experience with us. It's really been fascinating. I wish you continued failure in your retirement so that you continue contributing to this discussion. And thanks for all you've done over the many years. And what was a little bit new to me is also thanks for withstanding this onslaught that you got for just being a scientist and telling us what the truth is. So I know that's been difficult, but as you said, it was a fascinating journey so far. So I'm
well,
glad.
thank you for those kind words, Dan. You know, some things are worth fighting for, and a clear public understanding of the reality and seriousness and impacts of climate change, that's worth fighting for. And I'm proud of the fact that I've had the opportunity to make a small contribution to advancing the science, and I want to keep on doing that for as long as I possibly can. But thank you for providing a forum where people can communicate and try and explain this rich scientific understanding to others.
Great. Well, thank you. And just to everyone there, we hardly ever mentioned it, but please like and subscribe so that this program and programs like it are shared with more people. Again, next Sunday, July 27th, Peter Cox, interviewed by Leon Simons. And then a special day, July 31st, Stephen Chu, former Energy Secretary. And so we'll see you next time. Ben, thanks so much. Bye-bye, everyone.